Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is symmetric tree. First of all, let us start by understanding the question. What does question say? Given a binary tree, check whether it is symmetric or not. That is, whether the binary tree is a mirror image of itself or not. So what basically they are saying is, we are given a binary tree. So that means that each node can have either 0 child or 1 child, or at max 2 child, right? Left and right. Okay. So we need to tell whether that binary tree is symmetric or not. So whether it is a mirror image of itself or not. So if we take mirror image of that binary tree and compare both of them, they should be equal. Or if we draw a line in between, then the left part should be a mirror image of the right part. Okay. So if we look at the first example here, then if I draw a mirror image of this, it would be exactly same. Or if I draw a line from center, then this is a mirror part of this, or this is a mirror image of this. Okay. So basically the left and right part are symmetric. Okay. So here the left child is 1, here the right child is 1, here the left child is 2, here the right child is 2. If you draw a line from between, both of them are, both the parts are symmetric. Okay. So that's why the output is true. Okay. If we look at second example, then these are definitely not symmetric, and hence the answer is false. You don't need to read input or print anything. Your task is to complete the function is symmetric, which takes the root of the binary tree as its input and returns true if the binary tree is the same as the mirror image of itself, else it returns false. The expected time complexity is big O of n, where n is the length number of nodes in the tree, and expected auxiliary space is height of the tree, and the constraints are given here. So now if we think about solving this problem, so basically see, we are given a binary tree and we need to tell whether it is symmetric or not. So whether it is mirror image of itself or not. Okay. So basically if I take one example, so let's say this is 10, this is 12 and this is 12. So is it symmetric? Yes. How? If I take a mirror image of it, the 10 will remain here only. This 12, okay, this 12 will come here, because on the mirror it will be here, and this 12 will come here. Okay, and these two are exactly same, so we will say they are symmetric. Okay, what is another way? Just draw a line in between, and if you flip this, it will be these two will be equal. Okay, so if you flip it, it will overlap with this. Okay, or you can say if you take a mirror image of the left part, it will be printed on the right part, that is symmetric. Okay, so basically let's say one more example. So this is symmetric. Let's say I have 12 here, I have 12 here, and let's say I have 9 here and I have 9 here. Is this symmetric? No. See, here it is 10, here it is 12, 12, that's okay. But this 9 and 9, if this is the left child here, this should be the right child, then it will be symmetric. If I draw a mirror image, see, then what will happen? 10 will come here, right? Then this 12 will come here, and this 12 will go on the right side. Okay, then what will happen? This 9 will come here. Okay, if I draw it here, so this 9 will come here, and this 9, okay, this 9 will come here. Okay, now compare, is this equal to this? No, these two are on the left, these two are on the right side. Okay, so these are not symmetric. Even if you draw a line from the center, this and these are not mirror image of itself, and if you flip this over this, they will not overlap. Okay, so what we need to think of is that starting from the root node, if we move one step on the left, then on the right side we will move on the one step on the right. From here, if I move one step, so we will compare these two nodes. Okay, now from here, if I go to left, I will compare the right child of this, because it is on the right side. If I go here on the right, then I will compare the left child of this. Now, so basically these two will be compared and these two will be compared. Now from here, if I go to the left child, from here I will go on the right child, because we are comparing these two nodes. So this left child will be compared with this right child, and this right child will be compared with this left child. Okay, so basically that is what we need to do. So if we look at this example, so what I'll do, see, this node is common to both the parts. So what I'll do, I'll say check this node and this node. If they are not equal, return false. If they are equal, then for this node's left node, compare it with this node's right node, and this node's right node, compare it with this node's left node. This 8 and 8 are same, this 9 and 9 are same, so move further. So this node's left node, now I compared this 8 with this 8, right? So this node's left node will be compared with this node's right node, right? And I compared this 9 and this 9. So 9's left child will be compared with this 9's right child. Okay. Now these and these are also same, so we will compare further. Now we are comparing these two. So this node's right child will be compared with this node's left child. So everywhere it is equal. So basically, if we are comparing two nodes, one from the left and one from the right part, we will compare its value, and then for the left part's node, its left child will be compared with the right child of the right part node, and for the left part node, its right child will be compared with the left child of the right part node. This we will do recursively, and at any step until we do not reach out of the tree, and at any step if the values do not match, even if two nodes, okay, even if there is one mismatch, we will say it is not symmetric and we will return false. Okay, now let's look at its actual implementation so you will have a better idea. So if you look at the actual implementation, so what I have done, first of all, I have taken one answer variable and marked this as true. Okay, now if the root is itself null, then return true, because an empty tree is symmetric. Okay, if the root is not null, then what I'll do, see, root was common to the left part and the right part. So I call the check symmetric function, and I will compare the root left node with the root right node, and I'll also pass the answer variable. So whenever there will be a mismatch, I'll mark the answer variable as false. Okay, now if we look at the check symmetric function, I have to compare a node R1 with node R2, and this is the answer variable. Now if both R1 and R2 are null, so if we have come out of the tree, or they do not exist, then return true, right? Because if we look here, for let's say for for 20, now this is R1 and this is R2. Okay, now let's say I called left child of this and right child of this, so this is also null and this is also null, or 6 left child is null and here 6 right child is null. So null and null are symmetric, right? These are symmetric, there are no values. Okay, so if R1, the two nodes which I need to compare, if both of them are null, then directly return, because that's true. Okay, but if R1 is null and R2 is not null, it means I needed to compare R1 and R2. Now R1 is null but R2 is not null, so they are not symmetric, so I'll mark answer variable as false. If R2 is null and R1 is not null, then also I'll mark answer as false. If both of them are not null, then first I'll compare their value. If R1 data is not equal to R2 data, then make answer variable as false. If R1 data equals to R2 data, then recursively check for further child. Okay, so I'll call the check symmetric function, and if I am calling the left child of the R1 node, I will compare it with the right child of R2 node, because R1 is a node on the left side of the tree and R2 is a node on the right side of the subtree. So if I am checking the left child of R1, I will compare it with the right child of R2 to check symmetric. Similarly, I'll call check symmetric function, and if I pass the right child of R1, I'll compare it with left child of R2 and I'll pass the answer variable. Okay, so finally this will compare all the possible values, and it will make answer equals to false if there is a mismatch, and then finally I will return answer. What will be the time complexity? Time complexity would be big O of n, because we are traversing through all the nodes. Okay, what will be auxiliary space? The auxiliary space here will be big O of height of tree. Now why height of tree? Because I am calling this recursive function. Okay, so a call stack will be maintained, and at max how many elements can be there in the call stack, recursion stack? It is equal to height of the tree. Okay, now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.